Okay, here is our lecture video for section 10.6, find segment lengths and circles. Up to this point, we worked a lot with angles and finding their measurements. Now we're going to move on to learning some theorems about the lengths of different segments within a circle. And we have 3 theorems we're going to learn today. We're actually going to work out a few harder examples, and then your homework is actually easier than the notes. So if you guys are following along with the notes, make sure you get the theorems written down, and make sure you try the easier examples because that's what you're going to be seeing more often. So our first theorem is about segments of chords. And the theorem says if 2 chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of another chord. That's a lot of words for basically saying it's a multiplication problem. So I would make sure you guys get the name of that theorem written down and get that picture written down along with this multiplication down here. A word that pops up a lot in here is product, and remember product means multiplication. So if we have 2 chords intersecting inside the circle, we know that when we multiply the pieces of the chord, the segments together, they're going to equal the same thing. So in this case, EA times EB is going to equal EC times ED. So basically just multiply the 2 pieces together and they're going to be equal. So let's see what that looks like in an example. So we're just finding the length of ML and JK. Again, we know that we have that theorem we can use, and that theorem tells us that NK times NJ is going to equal NM times NL. That's what that theorem says we can do. We can multiply the pieces together. So NK times NJ equals NM times NL. And I'm going to plug in the values they gave us for that into this multiplication problem. So NK is X. I'm going to use parentheses to show multiplication. NJ is X plus 4. NM is X plus 2. Again, I'm going to use parentheses, and you'll see why in a second. NL is X plus 1. And then there's our multiplication problem. And the reason I said that we're doing some harder examples is because we haven't seen some of this math we're going to be doing in here since you've been in Algebra 1. This right here tells us we're going to have to FOIL. Hopefully you guys remember what FOIL means. It's first, outside, inside, last, and it tells us how we're going to multiply these 2 binomials together. So just kind of cleaning this up here, we know we're going to have to distribute the x right there. So x times x is x squared. Again, something we haven't seen a ton of this year. X times 4 is 4x, so then plus 4x. And over here, we're going to use this foiling method. So F in FOIL means first, so x times x is x squared. O is the outside, so x times 1 is just x. I is the insides, 2 times x is 2x, so plus 2x. L is last, so 2 times 1 plus 2. And then from here, we can combine like terms. So I can't do anything on the left side over here. This is still just x squared plus 4x. Over here, I can combine these middle 2 terms and get x squared plus 3x plus 2. And now this turns into a problem that I know we can all solve. The first thing we probably want to do is move the x squareds over, combine them. Cancels on that side. Well, when I subtract x squared over here again, it also cancels. So I'm just left with 4x equals 3x plus 2. I can subtract the 3x to get x equals 2. And the hard part's over. Now I just need to take this 2 and plug it back in to find what these lengths are. So to find ML, well, ML is both of these added together. So I have x plus 2 plus x plus 1 to get the whole length ML. And everywhere I see an x, I'm going to plug in a 2. So this is going to be 2 plus 2 plus 2 plus 1. So 1, 2, 3, 4, 5, 6, 7. ML equals 7. And we're going to do the same thing for JK. JK is x plus 4. Everywhere I see an x, I'm going to plug in a 2. 2 plus 2 plus 4 gives me 8. So they're not congruent. We didn't say that. We just know that the products of the segments are going to equal each other. And that let us find what each of those lengths were. Again, the problems you're going to be doing on your own, you aren't going to have to FOIL. You might have to distribute like we did over here, but it will just be with a constant number and not a variable. We're working through a lot harder examples together, so the homework seems a little bit easier. And then moving forward, we have some theorems that have to do with some tangents and secants, and we've done these definitions already, so you should know what these are. But just reading along with me, a secant segment is a segment that contains a chord of a circle and has exactly one endpoint outside the circle. The part of a secant segment that is outside the circle is called the external segment. Outside and external go together, and that's this red line up here. An external segment is outside the circle and it's connected to a chord. And then our tangent segment doesn't go through the circle, it stops at the outer edge. Remember, a tangent only intersects at one line, so it doesn't go through the circle. The secant part goes through the circle. So those definitions are going to help us with our last two theorems. The first of which is segments of secants, the theorem. Reading along with me, if two secant segments share the same endpoint outside a circle, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. So basically, again, lots of words can get a little bit confusing. I would make sure you guys write down the name and the picture with the little multiplication down here. And just a reminder, product means multiplication. And basically looking at this, it says EA times EB equals EC times ED. So we could think of it as the part times the whole equals the part times the whole. The part outside times the whole thing equals the part outside times the whole thing. And that's kind of how we're going to piece together our examples. So you have a multiple choice question here. Finding the value of x. Well, we have a secant. We have two secants and they intersect outside the circle. So I'm going to be using that part times whole equals part times whole. And the formula that we got in the last, you can kind of see it up top here, we're going to use that to set it up first. So we could say RQ is our part times our whole would be RP equals RS as our part times our whole RT. So then we just plug in the numbers they give us. RQ is 4. RP is 5 plus 4. RS is 3. RT is x plus 3. And that's where these get tricky because you have to add it together to get the whole. It's part times whole equals part times whole. Well, 5 plus 4 is 9, so this just changes to be 4 times 9. And I'm going to distribute this 3 here. 3 times x is 3x. 3 times 3 is 9. 4 times 9 we get 36 equals 3x plus 9. We subtract the 9 to get 27 equals, oops, can't see it, equals 3x. Divide by 3 to get the x equals 9. And that would be your answer. And these are the more straightforward ones where the hardest thing we have to do is remember to add these together and then the little distributing here. But no foiling, anything like that. So why don't you guys go ahead, pause the video, and try these two problems on your own. One using each theorem. Try them on your own, come back when you're ready to check your answers. Okay, number one's using that segments of secants theorem. So we're going to be using that part times whole equals part times whole. So right here, our part is going to be the 6 times the whole is going to be 9 plus 6. Down here, our part is 5 times the whole would be x plus 5. I always like to put x first because it makes the distributing just a little bit easier. 9 plus 6 is 15, so this changes to 6 times 15 equals, distribute the 5, 5x plus 25. 6 times 15 is 90 equals 5x plus 25. Subtract the 25 to get that 65 equals 5x. Divide by 5. X equals 13. And again, that's one of the more simple ones. These are going to be the type of problems that you see most often that I'll be expecting you to do on your own. Number 2 is using that first theorem, the segments of chords theorem. So here we're going to multiply the segments together to figure out what they should equal all together. So looking at this chord right here, we know that 3 times x is going to equal the product of this chord, so 6 times 4. 3x equals 24. Divide by 3, x equals 8. That one's probably the easiest theorem that we're going to have in this section. Usually the most straightforward. And the reason we threw this out over here is because it was a little bit harder than I wanted to teach over a video, so not necessary to do. So then moving on to our last theorem for this section, segments of secants and tangents theorem. Again, lots of words. If a secant segment and a tangent segment share an endpoint outside a circle, then the product of the lengths of the secant segment and its external segment equals the square of the lengths of the tangent segment. Lots of words, very easy to get confused. I would make sure you have the name. Do your best to draw the picture and make sure you get that equation written down. Basically, the tangent segment's the segment that doesn't actually cross through the circle. It stops at the outside of the circle. We're going to square that and set it equal to part times whole of the segment going through the circle. And that's our last theorem here. So again, just another equation we're going to be using when we have a different setup with the circle. So then let's try an example together. Now I'm just going to say this now before we get into this. This is a hard example. You guys will not have to do an example this hard on your own, but it's going to be good for you to see how hard these can be. That way everything you do on your own is a lot easier. So in this picture, we're trying to find RS, which is x, or trying to find x. This segment right here, the 16, is a tangent because it doesn't actually cross through the circle. And then RT's are secant because it goes through the circle and they connect out here at R. So we're going to be using that last theorem we just learned. And using letters, we know we're going to have this tangent squared, so RQ squared, and it's going to equal part RS times whole RT. Okay, so then let's plug in the letters and numbers we know. RQ is 16, so we have 16 squared equals RS is x, RT is x plus 8. So cleaning this up a little bit, 16 squared is 256 equals, we're going to distribute this x times x is x squared, x times 8 is plus 8x. And this is where it gets a little bit harder. Before, we had x squareds on both sides of our equations and they canceled out and it wasn't that bad to solve. But we don't have anything here to cancel out this x squared, which means we're going to end up factoring, which you hopefully got to at the end of Algebra 1. If not, this is going to be a little bit confusing, but that's okay. Just bear with me. Before we can factor this, we want it to be set equal to 0. So to do that, we'll subtract the 256 over to get something that looks like 0 equals x squared plus 8x minus 256. And when you were learning how to factor, you would say you want to find two numbers that multiply to give me negative 256 and add to give me 8. Well, that could be a lot of trial and error to get that. Or we can use this fancy thing called the quadratic formula, which is x equals negative b plus or minus square root b squared minus 4 times a times c all over 2a. And if you don't know this, this is okay. You will learn this in Algebra 2. If you do know this, follow along with me. Again, you guys will not have to do this on your own. These B, A, and C here are just the numbers we see over here from our standard equation. We have ax squared plus bx plus c, and it's just those coefficients. So plugging things into this quadratic formula here, we would get x equals negative b is going to be negative 8. My a's there, this 8 is my b, making the negative 256 my c. So negative b, negative 8, plus or minus square root, b squared is 8 squared, minus 4 times a is 1, times c is negative 256, all over 2a, which is just going to be 2 times 1. And again, this is hard, so hang in there. You guys won't have to do this on your own. I just want you to see it, maybe because if you have done it before, this could be a refresher. And we're just going to clean this up to find out what x is going to equal. And it's going to give us two possibilities because since we have x squared, we have two possibilities for x, and that's where this plus or minus comes in. So to clean this up, we're going to simplify what's in this square root right here. And just to make life easier, I'm just going to use my calculator, plug it all in at once. So 8 squared, 64. We all know that minus, I'm going to throw in my parenthesis there to keep my order of operations correct. 4 times 1 times negative 256 to get 1088 underneath that square root. All over 2. And if you have seen this before, you probably simplified this more, but we're not going to worry about that right now. And I'm just going to get my two answers by plugging it into my calculator. So I have negative 8 plus, one answer is going to use the plus, the square root of 1088 equals divided by 2. So one possible answer is 12.49. It's okay to round. And then our next answer, we're going to use the minus and do negative 8 minus the square root of 1088 divided by 2, negative 20.49. So there's our two possible answers. But if we think about it, x can't be negative, right? We can't have a negative length. So this answer doesn't make any sense, which means x is going to equal 12.49, which means RS equals 12.49. Again, hopefully you followed me until here, till this blue, what's in the blue, and then you probably weren't really sure where to solve. Depending on how far you got in your Algebra 1 class, you may have seen this before, you may remember factoring, it may have been a little bit easier, harder. But what I want you guys to try to do now is pause the video and try these two examples on your own. You won't have to factor, you're not going to have an x squared, so you won't have to worry about that. Well, you will have an x squared, but you'll know how to solve it. You just won't have to factor. So try these on your own. Come back when you're ready for your answers. Okay, so right here, number 4, we're going to square the piece that's just outside the tangent piece. So we're going to have x squared equals the part, so 1 times the whole, 3 plus 1 to give us 4. So we have x squared equals 4. And since there's not another x, we can just say, okay, well, the opposite of squaring something's taking the square root. Square root of 4 is 2. And that's going to be more typically what you'll see on your own. Number 5 here, our tangent piece is 7. So we have 7 squared equals our part. So 5 times our whole, 5 plus x. 7 squared is 49. Distribute here, we get 25 plus 5x. Subtract 25 to get 24 equals 5x. Divide by 5. We could get a decimal here, or we could just leave it as a fraction to get x equals 24 over 5. And that will be the ones you're more typically going to see. I'm not going to ask you guys to factor anything because we haven't learned it yet. Again, you'll learn that in Algebra 2. Just wanted to throw it out there because it was one of the examples in the book. So to wrap things up here, I have a few more I want you to try on your own. For 7, 8, and 9, I want you guys to determine which theorem you would use to find x, then I actually want you to find x for number 8. All right, so come back when you are ready to check your answers. Okay, so number 7 looks like we have a tangent and a secant, so that is going to be the secant and tangent theorem. And if you would have solved for x, it would have involved more quadratic formula, so that's why we're not doing it. Number 8, we have 2 chords intersecting inside the circle. So that's going to be our segments of chords theorem. And again, we know that that's going to be multiply the segments of the chords together, set it equal to the other. So we would do 18 times x equals 9 times 16 to get 18x equals 144. To get that x equals 8. Those are the type of problems I'm going to be asking you guys to solve, is when they're simple like that and something I know you know how to do. And last but not least, number 9, we have 2 secants, so that's going to be the segments of secant theorem. All right, so we learned 3 new theorems today. We saw how they could get harder to solve, but again, you guys are going to be sticking to more simple, basic problems, especially coming at the end of the year, being online. So your homework for this section is on page 684. The pages will also be posted on the classroom number 3, 4, 6, 9, 10, 13, 14, 17. And then if you are in honors, I want you to go ahead and do 18 as well. Again, you won't have any factoring on these or anything like that. These are going to be more straightforward, and that's why the numbers are listed out more than that, because I was particular about which problems I wanted you to do. There's your homework for this section. Please email me if you have any questions.